These notes are for AP Calculus AB. This is 8.9, your last objective for Unit 8. And in this objective, we will be reviewing solving differential equations plus solving differential equations involving integrating to natural log. And I will tell you that many years on the AP exam, the free response question about solving a differential equation typically involves a natural log. So these are especially important to remember the steps and what to do. So I've written out those steps again, and I want to remind you that we first learned solving differential equations back in Unit 5, right in the middle of the unit, so you might look back there to review. You always will separate your variables first unless you would like to receive 0 points. Next, you want to integrate each side correctly and add C. If there's an initial condition, you'll use it to solve for C, and your final answer should be written as y equals. And the order of these things could vary. It just depends on the type of equation you're given. Directions on problems like this typically say solve the differential equation. So that's what this is telling you to do. Go through these steps and solve for y. If you're told to find the general solution, this means that you're just going to have a plus C at the end, or you'll have a constant, just C in the answer. If it says find the particular solution, this means you are given an initial condition that you can use to solve for C. So that's the difference there between general solution and a particular solution. With that, I'm going to go through a few examples. And I'll start off with a bit of review of these types of problems. So the first question, dy dx is equal to x squared plus 2 divided by 3y squared. So in separating our variables, we want to have our x's on one side, the y's on the other. Remember that dy should remain in the numerator, and so it's dx that also needs to be in the numerator. We're going to multiply across here. So we'll want x's on the right. We'll move our y terms over to the left. Now it's up to you. Sometimes it'll benefit you to leave things like a 3 here in the denominator, but I can look ahead at if I move this term over here to the left and then I integrate it, that term by itself will integrate nicely just back to y cubed. So I'm going to leave the 3 with it and just separate the variables here. So we get 3y squared dy is equal to x squared plus 2 dx. So I've separated the variables. Now I'm able to show my integration, and I want to make sure I have a plus c as well. So over here on the left side, we get y cubed. On the right, x cubed over 3 plus 2x, and then plus c. Now, I was not given any initial condition, so there's no way to solve for c here, and my final answer just needs to be in the form y equals. So to get y by itself, I want to take the cube root of each side. Now on the left, you're not allowed to take the cube root of each term individually. It's cube rooting the entire thing, just like if you wanted to multiply by something. Okay, so raising it to the 1/3 power or cube rooting it. Now, unless you can rewrite the inside here as a perfect cube, which we can't, then there is no cube root for it. And so that is pretty much my final answer right there. Y is equal to, and you can leave it as a cube root or rewrite it as a 1/3 exponent. Okay, problem number 2. Root x plus root y times y prime equals 0, and y of 1 is 4. So instead of writing it with f of x, f of 1 equals 4. So this is y of 1 is 4, and it's telling us when x is 1 that y equals 4. So this is really a coordinate pair here, 1, 4, for the original function y. So this is an initial condition, which means I'm finding a particular solution to this differential equation. So you don't see the dy dx here, and that's because it's hidden inside of the y prime. So we're going to start by rewriting that. And if we'd like to start separating our variables, we'll need to move the root x over here. So I'm going to subtract root x over to the right. And then you'll notice I only want to keep the y terms here out of what's left. So I'm going to multiply dx over right now. And now I've got my variables separated. So again, I just subtracted root x over and multiplied dx over to the right as well. So now it's pretty much set up, except when I go to integrate it, I need these to be written as exponents. So I'm going to rewrite it. Y to the 1/2 dy equals negative x to the 1/2 dx, and then I can begin my integration here. So on the left side, adding 1 gives us 3/2. Dividing by our new exponent is to multiply by 2/3. On the right, x to the power 3/2 times 2/3 plus c. Now you could solve for the constant right now, plug in 1 for x and 4 for y. I would recommend though trying to get y by itself a little bit more. So if there's a coefficient, I would get rid of that coefficient, but not the exponent necessarily. So I'm going to multiply through everywhere by 3/2 first. So that'll leave me on the left with y to the 3/2, and on the right side a -1 coefficient, x to the 3/2, and then my constant times a number is still just plus c. Since I don't know what that number is yet, I can't multiply it by the 3/2. So it's just c times a number is just another constant c. So at this step, this would be a good time to plug in the initial condition and solve. So when x is 1, y equals 4. So 4 to the power 3/2 is equal to -1 to the power 3/2 plus c. So this is root 4, 2 cubed is 8. This is 1 to the 3/2 is 1. So then we multiply by a negative, and it's -1 plus c. And hopefully you know there's no parentheses around that -1. So it's not the square root of -1, it's just the square root of the 1. And then we multiply it by the negative. So this tells me that my constant is 9. So we would go back and plug this in. C is 9. Now to get y by itself, like last time, we just took the cube root of each side to get rid of the power of 3. Remember that cube rooting is the same thing as raising each side to the power 1/3. So the same thing happens here. To get rid of that 3/2 exponent, we want to raise both sides to the power 2/3. Just the reciprocal exponent will do. So we'll raise this side to the power 2/3, and we'll do the same thing over here on the right, power of 2/3. So I end up with y is equal to -x to the 3/2 plus 9, all raised to the power 2/3. And unless you know how to rewrite inside as a perfect cube, you can't take its cube root. And so this is how you'll leave your answer. All right, so these are still a little bit tough problems. We're going to get into some new things. So I think I'll just bring them up as we go through the examples. This is number 3. So again, y prime is your dy dx, and then we want to separate our variables. So let's rewrite that first. So I'm going to keep dy here on the left. So I need to move this y over, and I want all the x's over here on the right side. So I need to divide both sides by y. Okay. And then to move the x's over, so we're going to multiply dx over, multiply by dx. And then to move x squared plus 4 over, we'll need to divide by it as well. All right, so it's a little bit messy and we're going to rewrite it. So this is now 1 over y dy. 1 over y dy. So I moved that dx over, multiplied it over, divided by x squared plus 4, and I'm just leaving behind a dy over y, which we like to write as 1 over y dy. On the right side, you have x over x squared plus 4 dx. All right, there are the two sides. They seem to be ready to go, so we'll start with our integration here. So on the left side, you can see that's going to give us a natural log. On the right side, in order to integrate, we have more x's, a higher power in the denominator, so we might want to use our u substitution here. So if u is x squared plus 4, du is 2x dx, you have that x dx, but no coefficient 2, so you'll divide it over. 1/2 du to replace the x dx. So you'll throw in that 1/2 here and the du at the back. That takes place of the x dx, which leaves a 1 in the numerator, and the denominator x squared plus 4 is replaced with u. The left side is still the integral of 1 over y dy. So here on the left side, we'll integrate 1 over y back to the natural log of the absolute value of y. On the right side, we keep that coefficient 1/2. Integrating 1 over u is the natural log of the absolute value of u, which was x squared plus 4. So we certainly don't need to keep these absolute value symbols, plus c. All right, so no initial condition is given on this problem. So we're not going to be concerned with solving for c, but we are concerned with solving for y. So the first thing I'm going to do is take my 1/2 coefficient, rewrite it as my exponent, because a power of 1/2 is a square root, in which case I could drop the absolute value symbols even if I couldn't have already done that. So it's just a good time to. Now I just need to solve for y. I need to get y out of my natural log. So how do I get rid of natural log? Same way you would get rid of a coefficient or an exponent, by using its inverse operation. So the inverse of natural log is e. So we are going to e both sides of our equation. That is, raise both sides as powers of e. So now it's e to the power natural log y equals e to the power all of this, natural log root x squared plus 4 plus c. This is all in the exponent of e. So how do we simplify this? Well, the left side's pretty easy. We did this on purpose so that the two would undo one another and just drop down what y equals. The right side, though, can be simplified because of some algebra properties that we have. So I'm going to write those out for you. So some things you'll want to remember. Well, we just did this one here. E to the power of a natural log of anything, we'll just spit it out. So that's our log property. Now the other thing I want you to remember is if I had a to the power m times a to the power n, you would get a to the power m plus n. So you know this, but we haven't done this a lot. We need to use it backwards. So right now I have e to the power of an m plus n. So e, that's my base a, to the power m plus n. Okay, so m is the natural log and n is the c. So if I split it back up, it's now my base to the power m, so e to the power of the natural log of the root x squared plus 4 times a to the n, so my base e to the power c. So this is where it gets kind of interesting again. E to the power of a natural log, they undo one another. The stuff in the log is our what it simplifies to here. So that means this term right here is just going to undo one another and leave behind the root of x squared plus 4. So it's times e to the c. Now e is just a number to the power of a constant. Well, you remember earlier we took our constant and multiplied it by a number and it just stayed as a constant. So what happens with a number to the power of a constant is that it becomes a constant itself. So e to the c is just a constant. And so we put that constant right in the front. So it's c times the square root of x squared plus 4. So we'll get a lot of practice with this. And I'm just going to write it one more time. So y is equal to c times the root of x squared plus 4. So that is what our answer will look like. Okay, and we weren't given an initial condition, so we couldn't solve for the c value. And this is exactly what you might run into on the AP exam. Okay, so we're going to try one more, and this one's a little bit nicer, and I've seen ones just like this show up on the AP exam as well, so it's a really good one to practice. And I don't know if you guys want to make this note, but we might as well. E to the c is c, because we're going to see that again. All right, last problem here, number 4. Right, so this is a great FRQ that you might see come up on the AP exam. So it seems pretty straightforward, although there's a log hidden in here. There's an initial condition to solve for C, so this is a great example. So you're going to start by separating your variables. Remember, dy needs to remain in the numerator, so we're going to divide by y here. And it's best to write it as 1 over y dy. We'll leave our x squared over here in the denominator and multiply dx over to the right. So dy and dx should always end up in the numerators. You don't ever want to integrate where you have a 1 over dx and a 1 over dy, so that's bad. So this is how it should be written. Now, the left side and the right side, look at those denominators. Y is just y to the first, where x is squared. One of them integrates to a natural log and one doesn't. So you figured it out. 1 over y will integrate to a natural log, while 1 over x squared won't because it does not have a power of 1. So in order to integrate over here on the right, we'll need to rewrite this as x to the power -2 in the numerator. Okay, and we'll just integrate it like we integrate anything else. So over here on the left, this is the natural log of the absolute value of y. Over here on the right, we'll take x, add 1 to the exponent, divide by our new power, and add c. So don't use this just yet. Let's clean this up a little bit first. This is -1 over x plus c. If you wanted to use the initial condition right now, you would plug in 3 for y, the natural log of 3. That's not a number you're going to know. So let's wait on that and try to get y by itself first. To get y by itself, to get rid of the natural log, we're going to raise both sides as powers of e. So e to the power of the natural log of y is equal to e to this power here, -1 over x plus c. So I'm going to use my algebra property to split this up. So it becomes e to the power -1 over x times e to the power c. That e to the power c we just wrote down. E to the c is just going to be c. E to the c is just another constant. Meanwhile, on the left side, e and natural log undo one another and leave y behind. So I have y equals e to the power -1 over x times c. So I'm going to pull c to the front, e to the power -1 over x. This would be a good time now to plug in the initial condition. So we'll let y be 3 when x is 1. All right, so -1 over 1, c times e to the power -1. So 3 equals c times e to the -1, or 3 equals c over e, right? We would just bring e underneath the constant, +1 power. I'm solving for c, so I need to multiply e to the other side. c equals 3 times e. So we're going to take that and substitute it back in here. So I have 3e times e to the power -1 over x. So to finish, we're just going to use that algebra property and multiply the two e's together by adding their exponents. So coefficient 3, e to the power 1, and then we want to add it to -1 over x, and we'll write that as 1 minus 1 over x. So that will be our answer there. All right, so we will get more practice with these in class, and I'm sure that you will only get better as you practice more and more of these, but that is the end of our notes for 8.9 and the end of our notes for Unit 8.